Morning, colleagues. Morning, colleagues. Morning, everyone. Good to have you here. It certainly is a wonderful opportunity for us to get in this fashion to be able to have discussions on factors relating to our continued webinar series. As we continue, we have an important and an intriguing week 4 in prospect, and
Dale, we're not hearing you. We are hearing you now, Dale. That's all right.
Great. I said what I was going to do was to introduce both speakers, and then we could move seamlessly to the presentations. And after we've completed the presentations, then we'll go to the Q&A section, which will be jointly handled by the speakers. CARDI's West Indies and certification in project management. She is the lead on CARDI's integrated pest management group and is CARDI's representative on the Caribbean Plant Health Director Forum. Mrs. Harris's experience spans over 20 years, and she has written and co-authored various publications on integrated pest management and invasive species. So we have a lot of experience there and knowledge from Mrs. Harris. With respect to Dr. Dwight Robinson, Dr. Dwight E. Robinson is a senior lecturer and head of the Department of Life Sciences in the Faculty of Science and Technology at the University of West Indies, Mona campus. He's an entomologist by training and specializes in the management of arthropods, pests in the tropical islands ecosystems. He has, over the last 30 years, he's been involved in research related to various aspects of pest and pesticide management, as well as ecological composition of different agricultural ecosystems in Jamaica. He has more recently widened his research interests to the development of sustainable agricultural production systems, inclusive of organic and eco-friendly agriculture. So Dr. Robinson brings to the table himself and Mrs. Harris, not just experience in integrated pest management, but a multidisciplinary approach towards the whole notion of climate smart agriculture. And therefore, I'm very, very happy to have both of them here. They're not just colleagues, but they're friends, and I'm sure that they're going to do a wonderful job. Help me then, ladies and gentlemen, to welcome to speak to us first, Mrs. Harris. Mrs. Harris, you have the floor. Thank you very much.
Hi. Hi, Dr. Rankin. Hi, Dr. Rankin. Sorry about that, everyone. But Dr. Dwight Robinson would actually be presenting first. So, yes.
Okay, my apologies for that. Dr. Robinson, my apologies, sir. I am accustomed to doing ladies before gentlemen, but they say Adam was made before Eve. So forgive me for that, sir. Can you go ahead?
Thank you very much, Dr. Dale. Thank you. I fully understand that. And I know the gentleman you are, you would have gone and thought the lady would have gone first. No, it's just a case of sending the brute before the beast. The beast before the brute, before the beauty. So thank you. I'm happy to be here. I want to thank you all for the invitation to be part of this. And I hope we can initiate some discussion. I'm going to try to share my screen. I'm going to try to focus on this in a general way, and my colleague, Mrs. Clark Harris, will focus more on specifics. So I'm assuming that my screen is now visible. We should be good to go.
Yes, it is, sir.
All right, great. Thank you very much. All right, so fellow participants and colleagues across the Caribbean, I'm grateful for being a part of this opportunity. We know the issues we have with climate change. We know how it's impacting all our lives. And we are talking about being climate smart and looking at climate smart agriculture. And today we are supposed to focus on integrated pest management. Now, we tend to look at things in isolation, but that when we're talking about pest management, can't do it just thinking about pests in isolation. We have to look at it in a holistic way. And so for us to do that, to just be clear on what are the major things that we are concerned about from a pest perspective in terms of climate change. So we know basically what it is that is causing this effect. We produce outside and we sequester. So on the normal systems, as a life scientist, when you look at any ecosystem, all ecosystems naturally, without human intervention, produces carbon dioxide. But what happens is that usually it's neutral. The amount that is produced is also reabsorbed. Because of human issues or the intervention of human beings, we tend to have created an imbalance where what we have done is that we produce more carbon dioxide than we sequester. And so because of that, we end up with the whole greenhouse effect, because carbon dioxide is a greenhouse gas. And of course, with that, we have certain impact taking place. So what is the outcome here? We are projected to have increases in temperature or precipitation pattern changes. And of course, sometimes we have extreme weather events. All these things have a serious impact on pest situations, pest problems. So you're thinking about temperature, and we know most of the organisms, insects that attain pest status, all insects are cold-blooded. Now, they require external temperature for them to develop. And increases in temperature does have an impact on their rate of development. Precipitation does affect certain pests because moisture is very important. Now, there are times when excess of either of these can be bad. But there are times when that increase favors organisms that attain pest status. The organisms that tend to be hurt are the ones that we consider as beneficial, but the ones that attain pest status tend to benefit more from these things. And again, when you talk about extreme weather events, sometimes they can knock a pest population down, but there are times when it causes a transfer of the pest problem from one place to the other. So just to get a little bit more on the effect that we have in terms of our pest situation because of climate change. Rapid reproduction. And I will show a graph after this that indicates exactly how temperature impacts on the rate at which an organism completes the life cycle. So we're going to be increasing the rate at which they reproduce. And so those organisms that have attained pest status, of course, will be more abundant, and you get more frequent pest outbreaks because of that rapid reproduction. So where you may have had a crop in, and you had a situation where after, for the life of the crop, you would probably only get 1 or 2 pest spikes. Now you end up getting 3 or 4 because of the shortened life cycle. A major problem that we face with pests because of climate change, that there are some areas that were the conditions because of temperature, etc., were never conducive to certain species doing well. Because of changes in temperature, they are now able to expand their geographic range. So for example, in Georgia, there are some areas in the Blue Mountain where farmers were able to produce some things without any pests because of the temperature there. Now we are seeing. So I'm sure that if you look at in other countries, you will see that where the pests are getting to higher altitudes because of climate change. Their survival rate is going to increase because it's more favorable. And so you're going to have not just more frequent pest outbreaks, but bigger pest outbreaks. All of those things are possible. And with all of this nice condition and with human beings moving around, you're going to have them being moved from one area to the next, and where sometimes they may accidentally be moved to an area and the conditions were not favorable for them to establish and develop. Now you're going to have a situation where they are able to establish and to develop. Now, if you look at this graph, just to show you the impact temperature has on the time it takes for an insect to complete its life cycle. And you can see as temperature increases, that time is shortened drastically. And that's why in the tropics, we end up, most of our insects complete the life cycle in 21, 22, 23 days. In other climates, it takes 2 months for them to complete a life cycle. And so because of that, we have a greater pest pressure. And as temperature increases, the possibility of that shortening even further is real. And as a result of that, we could have a situation where we just get more frequent pest outbreaks, and because of surviving, things get a lot better for them and worse for us. Now, I want to just draw attention to this diagram that was put out by UNEP. And if you can see the whole thing where, as I said, we need to take a holistic approach. We tend to have been cultured in an environment where we focus on the crop that we do and what we are doing and the organisms that attack it, and we try to get that organism. We're not taking a holistic look. We are operating in an ecosystem, and we need to focus on that ecosystem. And what we need to ensure to maintain the health of the ecosystem, whether it's in agriculture or just the space in which we live so we can have healthy lives, is to ensure that we maintain biodiversity, we maintain a healthy ecosystem. And now we should not be blaming climate change for climate change is one of the things based on how human beings have dealt with the ecosystem. That's what has resulted in climate change. But climate change, as it stands, continues to have an impact on our ecosystems and contributes to poor ecosystems and low diversity. Now, having said that, I know sometimes people tend to focus on climate change mitigation and not really focusing on ecosystem-based adaptation. We just need to fix the ecosystem. And of course, in fixing the ecosystem, then of course, climate change mitigation will be an outcome of that. And so even in our situation, as we look at pests and how we deal with pests, we have to take this ecosystem-based approach. It's not for us to go and start picking off species that have attained pest status and say, I'm going to get that one. It has to be looked at in terms of the entire ecosystem and how we are managing that ecosystem in order to ensure that, first of all, we don't have such frequent pest outbreaks and they're not so large. And of course, we can get ecosystem service to assist us in reducing pest numbers. And then when we do have to intervene, our interventions don't have to be so many, And they don't have to be so intense, and they don't have to utilize some of the more hazardous things. I just want to draw your attention to, just to remind you of what a natural ecosystem looks like. It's one of the things that bothers me, that as we see students coming into the university, some of them have lost any idea of what a natural ecosystem is like. They see a natural ecosystem and they think it's a bad thing, when really and truly, we should know that, okay, there's a natural ecosystem out there, and yes, we have to adjust the ecosystem in some ways for us to survive, but we have some natural ecosystem that provide ecological service that keeps us alive where we are. But if you look at this natural ecosystem, you're seeing that there's diversity, and you have, species richness usually takes place, is present in these ecosystems. But what have we been led to believe in terms of our agricultural ecosystem? We have been taught that this is how we create an agricultural ecosystem. What are the characteristics of this? First of all, it's a monoculture. You pick one and you plant it all the way through. Now, for you to maintain such a system, it usually requires very high input. And yes, you hope that if you get the inputs right, you will get high output. And the focus you get in these systems is that it's more pest control, because you don't want anything to attack the ecosystem. Now, what I want to point out here, that type of monoculture system is unnatural. It goes against everything that is in nature. And what you have to understand is that once you start pushing against nature, nature is going to push back. And if we never learn that, we would see it now in the current pandemic. And we see how poor we're doing at winning this one. You just cannot win against nature. And so you need to ensure that you don't push too hard against nature. And so when you have a monoculture, I've always pointed out, and people tend not to realize, nature is always going to try to move back from the monoculture you have created to something natural. The first and best way for nature to remove that monoculture is to have a pest species wipe it out, one that you call a pest species. So the minute you put in a monoculture, you are setting yourself up for a fight with nature, and so all of a sudden your pest problems are going to be greater. And that is why people are now looking at polyculture. The problem we have here is that there's too many of us who still think that monoculture is the way to go, and we have not invested enough in doing the necessary research in polyculture. People will tell you no, that polyculture may not be very useful. It isn't, because we have not done the research and made the adjustments to develop economically viable want people to start making a shift in mind to see how we can get. So what are the changes we need? First of all, I want to point out all that I've said so far. How do we change our mind? That mindset that we have, that we think that a good agricultural system is one that is monoculture, just one crop. And while you can have something like, nothing is wrong with saying, I have a coffee-based ecosystem, or I have a cabbage-based agricultural ecosystem, because that may be the dominant crop, but it should not be the only crop. And one of the problems we have in the Caribbean, because the Caribbean is our mainly island ecosystems, when you go across a small lot of land, the diversity is so high that you are destroying several sub-ecosystems in order to create your farm. So you'll hear people coming, and we have it happening in Jamaica right now, where you get people come in and say, oh, we're going to bring new agricultural technologies to Jamaica. And they look at a spot of land and they want to wipe out 100 acres, and say that's what they're putting there. Now, when you go across 100 acres in an island ecosystem that is featured on high biodiversity, you have negatively affected several sub-ecosystems. And that's where you start to put up a battle with nature you can't win. And so how do we change the mindset to say the Caribbean islands are unique, and you have to design systems that fit these islands, that do not result in nature fighting back at you and throwing a bigger pest problem at you? How we change that mindset is very important. And when we change that mindset and change the way we think, our actions will differ. We will not feel that we have to, in setting up a farm, we have to clear everything, and reduce biodiversity because only the crop and planting is important. You will change those actions, and then your farm ecosystem will be what it is, not just a farm, but an ecosystem, and an ecosystem that has diversity. And that diversity, will then ensure that you do not have the pest outbreaks, you do not have the frequent pest outbreaks. And while not saying you won't have, but they won't be so frequent and they won't be so intense. And then you are able to better manage them because you have an ecosystem that's helping you along, because it's not natural for one species to dominate. So even once you have a balanced ecosystem, pest numbers may go up, but it's not gonna wipe you out. So in terms of the change that we need, if we're doing climate smart agriculture, we got to reduce the carbon footprint.
So Dr. Robinson, just 3 minutes ago.
Yes, sure. Right. So you can't have it because if you do not reduce the carbon footprint, you can't do what it is. You got us in the problem, and we still have this situation going. We just have to focus on balance and establishing a more balanced agricultural ecosystem, one that increases biodiversity, enhances biological life cycles to improve the ecosystem, so we can get the ecological services. So mixed cropping, reducing tillage, because those things do disrupt the ecosystem as best we can. Crop rotation and all of these things help to create a more balanced ecosystem that will result in us not increasing the pest load. And so we need to shift. We have to shift from this whole idea of control to pest management. I just want to remind you of the principles of management. It's not that you're going to try to eradicate. I still hear people talking about eradicate. We don't eradicate. We suppress populations to an economically acceptable level. We have to know that we can't go for one thing. People still rely too much on chemical control. You have to set different on right, to see if you can integrate them in a way that they're complementary. We can't go in with one that knocks out the other one. We have to monitor because we need to know the economic injury levels. When does the pest start to create economic problems for us? And where do we need to take the action to prevent them from creating that problem? Synthetic pesticides, especially highly hazardous pesticides, are a last resort. We don't go for them first, and we go for them first too much in the Caribbean. And of course, we must not just see our farm as the management unit, the whole ecosystem. Our farm is part of a bigger ecosystem. We can't just do things that just ignore the ecosystem. That ecosystem provides ecological services for us, and we need to be aware of that and see how we can utilize that ecosystem to help us suppress our pest problems. I'm showing you here a situation with just some organisms. And while you may look at some of them and think they're not good, all of these organisms are beneficial, or we have things where we may have one that's not so beneficial. We can see an organism assisting us to suppress the population. What I want us to do is to say, open our minds, and we can't get up and think there's a magic one we can wave across. Every farm system is different, and we need to focus on them separately. We need to try to understand what nature has provided us and how we can manage it to sustainably in a sustainable way. That supply ecosystem, we won't have so much pest problems, and the things my colleague will tell you, you'll be able to implement those on the few occasions that your pest population goes up above the threshold. Thank you very much.
Thank you very much, Dr. Robinson. Very, very excellent presentation, really, really clearly articulated. And so I really appreciate that very much. We're going to move to our next presenter. Mr. Pest, you are next. And I noticed that the numbers have gone up. So I want to welcome all those who have joined us. We are looking at integrated pest management today. Dr. Dwight Robbins, who is the Head of Department of Life Sciences. And now we're going to hear from Mrs. Clark Harris, who is a CARDI representative here in Jamaica. Mrs. Harris, you have the floor. Go ahead, please. Thank you.
Yes, good morning, everyone. Morning, participants in particular. Thank you, Dr. Robinson, for making my task here this morning very much easier than it would have been had you not given me that great platform to now go into my presentation. Okay, everyone is seeing my screen, I'm assuming. And from the pictures on the front, you will see that I am just going to be looking at aspects of pest management and where we need to be going with integrated pest management under a scenario of changing climates. I want to recognize the donors and the partners in this project. My outline is to give you a brief introduction, just to work my way to where you want to hear of what you need to be doing in this scenario of changing climates. And we want to just gloss over for reinforcement some of the impacts that are expected that Dr. Robinson went into, and climate smart agriculture compared to IPM. Why are we looking at both of those as part of what we need to be doing? How does IPM really fit? And some of the considerations we'll need to have as we develop our strategies for changing climates. So what is a pest? Dr. Robin mentioned not everything we see is bad. And so this is the working definition I want you to have in your heads as I speak. We're talking about any animal, plant, or any other organism that is in conflict with what the human being wants to do. I know that Dr. Robinson passionately opposed some of the things that we want to do as human beings. So we really should also not want to be in conflict as humans with nature. So any organism that would be weeds, insects, mites, plant pathogens, including vertebrates as well, which we all often forget when we talk about pests. And some of these pictures that I chose are to show you the types of inconveniences caused by the various types of pests, from defoliation to just a lot of species interspecific competition with the crop that we want to produce. And the bottom picture is actually a pepper field, if you believe it. So the quantification of what we lose because of pests is not very much in the literature, but this is in US billions of dollars for some of the regions globally where we are losing a lot to pests. Dr. Robinson spoke about some of the impacts that climate change will be having on the environment and therefore facilitating increased problems with these pests. And for ease, I have listed them concisely there. And he mentioned some of those and how they affect. But under normal conditions, this is what we have some of the weather conditions impacting on. So you have the flood and the heavy rains that will increase disease damage. Also, it will increase dissemination of soil-borne pathogens from infected to non-infected areas. Drought can do some damage as well in terms of increasing impact of pests, where you have outbreaks of some types of pests, mites, armyworms, are some of the main ones that especially vegetable producers will be familiar with. We have vectors of disease that are also prolific during drought periods. And we have also what we cannot control much of, the storm and air currents that bring in diseases from other places, sometimes outside of the country. So we have introductions as well. So what are the impacts of this climate change on the pests themselves? As I mentioned, you're going to have increased invasions and increased proliferation of pests. We're going to have increased temperatures affecting and rainfall affecting species migration because their habitats will be impacted. They're no longer comfortable under those circumstances, and we will have migration to new areas. Climate change will also impact the genetic makeup of the species, range that the species operate in, and the interactions between those species in that ecosystem that Dr. Robinson mentioned. So you're disrupting nature as the climate changes, because we have to find where we are most comfortable. The damage increases because stress on crops would be greater in terms of the crop's vulnerability and susceptibility to the impacts of these pests. Decline in native plant species, I did say the increased stresses on these plants would rule them out, and then you will have the replacement by other species. So we're going to be affecting our natural ecosystems in that way. High CO2 levels, natural crop defense mechanisms as well, and as well as levels causing predator-prey relationships. So the natural enemies do not function as they would efficiently. And also you have the lowering of the nutritional levels in leaves, leading to higher consumption rates by pests. So these are some of the things we are facing with our changing climate. Now, climate smart agriculture and IPM. I have put these slides together to just show the complementarity of IPM with climate smart agriculture principles. So we're looking at sustainable methods to increase productivity in climate smart agriculture. We're looking at resilient agricultural systems that will adapt to the changes in the environment. And we're looking at mitigation measures that will minimize the emissions, carbon emissions. We also, in climate smart agriculture, are looking at various practical management tactics that we can use to adapt to the changes that we're having in our ecosystems due to the changing climate. And this adaptive strategy, in large part, will also have an effect on managing pests. So the result, enhanced biodiversity, increasing yields, and the lowering of greenhouse gases. Dr. Robinson went through some of the perks of IPM that we embrace. And if you look at the highlighted words in blue, you will see that there is complementarity with the climate smart agriculture principles in terms of sustainability, impact on health and environmental risks. And he also spoke to the principles of IPM. I want to underscore these three, that we need to be monitoring. We need to think of the entire ecosystem, which Dr. Robinson's passion was sufficient to underscore. And we also need to look at chemicals as the last resort, and also to just knock down the populations and help us with elimination of some of those new invasions. So when you're looking at an IPM package, this is what you want to be doing. You're looking at the agro-ecosystem and you see that that is at the top of this wheel. And you're looking at all of these components that impact on the pests of concern. The crop is important. What has happened before in that system, in that ecosystem is important. And also aspects of the biology will inform how we make our decisions with respect to managing these pests of concern. Well, I don't want to use the term pests of concern, but the pests that we are focusing on. Monitoring is critical. We have to see in the past presentations on systems, it was highlighted when you monitor, you miss the interventions and prevent resources into the system to try and cure the situation. So the approach to IPM should be prevention, containment, and elimination if we fail to prevent, and then decide how we will cope if the if the incursion is entrenched. So those are some of the things that we want to consider. I know that people think like a lot, and it is because a lot of what informs what you should do is resident in various disciplines that impact on how we manage pests. And so this is where the use of ICTs in recent times, we have embraced this. Computer applications can be used to package these information that we can have the farmers readily access them and make real-time decisions on how to proceed. So what are the considerations when we're developing the IPM strategy? And I am going to deviate from how we do the pest management presentations and just focus on those things that are specific to the changing climates. What are the considerations? In the climate smart agriculture model, C-SAC, the focus is on resource conservation, energy use, safety, biodiversity support, and greenhouse reduction. So as I go through, you will see how some of these interventions can impact on those to make your system more climate smart. So we want to efficiently use our resources, and we should therefore focus on multi-benefit interventions. And in this first slide, you will see some of the interventions that we take for granted as part of agriculture, but they have multiple benefits, including the management of pests, which when we're doing them, we don't really think of that as our objective at the time. So proper site selection. If you select a site that is known to proliferate pests of the crop that you want to plant, you're setting up yourself for disaster. If you're selecting clay soils and waterlogged soils, you're setting up yourself for disaster. Site selection, proper site selection. Soil testing. When your plant is very well managed in terms of its nutritional needs through soil fertilization, well, soil fertility management rather, then you have a great start to your crop. Your crop is more robust. It is able to tolerate and in some cases resist the onslaught of pests. Water management. Enabling environment for many pathogens is excess moisture. So you want to avoid waterlog for that. But excess dry conditions also debilitate your plants. And I want you to pay attention to the photos at the side. This is a pepper plant under extreme drought conditions. Now, can you imagine that this plant is not receiving any water, and on top of it, it has a population of sap-feeding insects, aphids, scales, or mites as arthropod pests? That is just a double plant is unable to fight off or it's extremely stressed, and so productivity will decline. You can select crops that are tolerant to the pests that you anticipate or to drought conditions. That's another way that you can go around managing your pest impacts. So crop selection is very important. Dr. Robin spoke about multi-cropping systems. Multi-cropping systems have various benefits. Multiple crops that you choose could have different functions. You could have better crops, you could have site-adapted crops, as I mentioned. You could have crops that attract your natural enemies to your location to help you with the management of some of your pests. And this crop environment would have host and non-host plants of the major pests that you anticipate on your crops, your commercial crops. We're looking still at multi-benefit interventions. We have a lot of sun. Why not use it? We are grappling with how we're going to find alternatives to these herbicides that are being phased out or being considered for phasing out. How are we going to manage the pest populations, the weed populations in our field? Soil solarization uses the resources that are increasing on the climate change, the sun, to suppress weeds by dealing with weeds, killing the weeds that are present in the seed bank that is present in the soil, and some other pests like nematodes and plant pathogens that are soil dwelling. Seed selection. I spoke of the field being the first step in managing how the pest impacts the crop, and we're talking about true and can have an impact on your productivity. And if you start with pest and disease-free certified seeds where they're available, you have a good start. I put deliberately a coconut seedling because we don't always think of seed as these types of planting material that we start out with. We have proper land preparation having multiple benefits with weed management, improved water penetration, exposure of soil pests and predators, and the incorporation of organic matter, which promotes soil health as well. Mulching is another one where we enhance the soil structure, especially when we're using biological organic material that can be incorporated into the soil afterwards, or break down as they are exposed to the elements. We have microorganisms that are more encouraged in these mulch situations as well as the retention of soil moisture, which is important as the climate gets hotter and weeds are suppressed by mulches. I want to bring your attention to the mulch at the bottom of the slide, which is also silver. It's reflective. And some studies have shown that reflective mulches can deter some pest landing ability. And so, especially with aphids in peppers, that's one of the considerations for integrated pest management, reflective mulches. Protected structures. We covered protected agriculture earlier in the series, and so I wasn't going to dwell on that, just to say that protective structures also help in management of pests. They prevent the entry of these pests, and at the same time, they can keep off some of that intense heat, depending on the circumstances. The two pictures are structures that have been used in our research in CARDI. This structure, we have the vegetable amaranth growing in as an exclusion cage. This is a purpose-built cage that is for excluding the major pests. The mesh size that you use in these structures must be a barrier to the pests that you want to keep out so that you don't have them coming through. And you also want to be able to have adequate ventilation. Sunlight must also be sufficient for normal growth. We have cabbages on the row covers, and these two examples were to show that you can have extremes in cost of these structures. So you have low-cost structures that you can consider as well. And also you want to think about how do you collapse these structures if something threatens, a storm threatens, a hurricane threatens. You want to be able to take them down quickly and put them back up. The exclusion cage was designed with that collapsible element, and some of the greenhouses also are designed for easy collapse in the event of a threatening storm.
Sorry, Mrs. Harris, 2 minutes to go, please.
Sure, no problem. So biological control remains a major contribution when we're talking about pest management for changing climates, because we're going to be having increased invasions. We're going to have to then go to the countries of origin to import the natural enemies to help us to manage the pest. We have to master and release natural enemies that are existing or imported. Pesticide application remains a part of our reality. And We must also remember that when we talk about pesticides, we're not just talking about the extremely lethal ones. We want to focus on looking at the safer ones, how we can make them more effective. And we also want to look at personal protective equipment. With hotter temperatures, are we really going to be able to do this? This is a lightweight one that is really better than what has obtained in the past. But do we also need to look at this, where we do not have a physical human being present to apply some of these more toxic types? Also, as we talk about range changes, will we have these pests migrating to areas that we have to access and that are not easily accessible? We look at drone technology, how can that also assist us as we move forward? Just wanted to mention some of the resources that we used here. And as I said, I just pulled out some examples that were very relevant to climate smart agriculture as with respect to what are some of the changes that we expect in the climate. So thank you very much.
All right, thank you so very much. Much appreciated. Madam Harris, really appreciate the time of the presentation, and thank both of you for sticking to the time limit that we have. As we have said, we really want to interrogate the information. And so at this time, the floor is open for questions. You can pose your question. When doing so, we ask you to please identify yourself, the agency that you represent, and also if you could just let us know to whom the question is being posed, whether it is to Dr. Harris, who calls himself the Beast, or is it going to be to Ms. Harris, who I think is the Rose. So please go ahead, please. Thank you. Any questions from anyone? No. Dr. Robinson, are you still online, sir?
Yes, I am.
Okay, I wanted to ask you a question. Maybe I could start the ball rolling. You mentioned the whole notion of monoculture and the challenges associated with that. How do we treat with that problem, though, in an era where you have large spans of agricultural lands, sir, under production with monoculture for the commercial production? Is it that you're proposing that we should have some kind of intercropping even in those large commercial farms that are not so disposed? What would be your recommendation?
All right, thank you very much. I know people, that's one of the things people always are concerned about when they talk about large, because they think once you go large scale, it has to be monoculture. When I look at some of the large scale farms that have gone around, there is this tendency, because a monoculture, yes, you could be focusing on one crop, but there are areas in it that you could leave under natural ecosystems, so you can get those ecological services. So you look at something like sugarcane, and somebody goes and they push down a large acreage. Nowhere in it have they left a band of anything natural at all. So I can understand they may wish to just focus on sugarcane. But if you're not gonna put any crops, any other crop there, you should at least leave an area that is maintained with some natural vegetation to provide you with some ecological services. I've seen in the past where I did somebody who was in large scale agriculture, and we're having this discussion, and they were planting 2 crops, and they just felt they had to do 2 of them in 2 large scale things. And because they said machinery could not work. And when I pointed out, it was that the machinery just covered 4 rows, and they could have planted 4 rows of one crop and alternated with 4 rows of the other one. And so they could still have used their machinery. But what happened is, because I think we are so locked into the thing that only monoculture can work, that we refuse to think outside the box and look at ways that we can maintain the biodiversity that we need to ensure that we don't have this tremendous problem we have with frequent pest outbreaks and very devastating pest outbreaks.
All right, excellent answer. Okay, I see a questions flying in now. So do I have permission to call you Dwight and to call Mrs. Harris?
That's the name I was given, sir. You have all the permission to call
Thank you,
me.
Dwight. Okay, so let's start. I think it's on the mic for Dion. Dion, it's to say,
Absolutely.
is there a regional supplier for ladybirds or other biological pest control? Do you know about Dion by any means, or Dwight? I don't know if either you want to take that one. Ladybirds, do we have a regional supplier for that?
No, I'm not aware of any regional supplier. Ladybird beetles, however, can be very easily reared in cottage type operations. So in one of my slides, I did mention laboratory, well, mass rearing, not laboratory rearing necessarily, because these can be done in cottage industry type operations. So it's just to enhance the capacity for that to be done.
Okay, do I know of any suppliers?
Yeah, I'm not aware of any suppliers. I am aware though, a couple of years ago of somebody who was trying to get into that field. But again, if you're not moving as a country, and at that time, there were too many obstacles because, you have all these permits and things, different things, etc. And so it was a challenge. And, based on what Dion is saying, what we need to do is to just change the way we think, change the mindset, and start realizing that we need to get to a stage where instead of somebody feeling that the only solution they have to walk into a farm store and buy a synthetic pesticide is that they could go to somebody who supplies and buy a supply of ladybird beetles. The technology is there on how to rear them. But we just have not gone that path because we're still thinking inside this traditional box. We're not thinking outside the box. But apart from that, as I say, setting up an ecosystem, sometimes you probably don't even have to rear them because if you set up a diverse ecosystem, they automatically will thrive there and do pretty well.
Okay, thanks very much for that. Steve Maxime, I saw your hand up. Do you still have your hand up, Steve?
I don't know, but I wanted to make a comment before you started your questions. I want to just endorse what Dr. Robinson has been saying about biodiversity support. And one of the key components of C-SAC, of this climate smart agriculture compliance, is this heavy reliance on biodiversity support to recognize that you cannot have a genuine climate smart agriculture operation without benefiting from the ecological services and so that reside in any well-planned operation. Even if, I mean, to be controversial, even if it appears to be a monoculture, at least one would understand the need for protection of the surrounding areas, because fortunately, many of the farms that we're talking about, that we're considering, aren't really extensive holdings. So in a 5-acre operation, even if it's a monocrop, you still have the perimeter crops, the perimeter foliage and perimeter vegetation that might make a difference. So that's what I wanted to comment on. Thanks.
Okay, Dion, anybody has any comment on that comment made by?
No, fully endorse it. I just fully endorse that. And that's exactly what we're saying.
Yes.
That biodiversity.
Fully endorse Steve,
Yes, I do agree with the statement as well.
Dion, you agree with me?
Yes.
I find that very strange. I mean, anyway, COVID is happening, so we shouldn't be too worried. I mean, strange things are happening. Okay, so there's a question here from Amira. How do you measure climate change? Well, climate change in the general sense, I mean, I don't know, I mean, being a scientist myself, I mean, Steve could answer that question. But the measures of climate are in general the parameters that we actually use to define the mean climate of a location. So for example, you look at the temperature, what the rainfall is doing. Generally, there are other measures, you look at the relative humidity, you look at soil moisture, all of these kind of things. And you look at them over an extended period of time. So you don't just see a spike in climate today or a spike in temperature as the climate has changed. In general, it refers to an irreversible change. So for example, we have moved from having in the 1990s 8 to 10 storms per year to more 11 to 15 storms. We will not go back down to 8 storms on average, right? So it's a permanent and irreversible change, and it is usually a change that is influenced by human activity, all right? Because as Dr. Roberts had pointed out, that there are changes that occur by natural occurrence, right? But these are changes in natural thing. But there's a lot of information on that on the IPCC website. And so, you know, I wouldn't want to bombard this discussion with that, since there's so much information available. But if I could continue questions that we actually have, there was a question here, there you asking if temperature has a parasitic internal worms. You probably could tell me what that is.
Okay, I think that is referring to intestinal parasites of animals. I would expect that the temperature effect on the animal itself will increase the stress that it's under, and therefore its level of tolerance to a parasite infestation on top of that. But just to also say to that person that there's going to be a livestock session on this, and we will have persons better able to respond to that question. But to my mind, it's really the impact on the animal that is the effect of the temperature, and then the stressed animal cannot tolerate the parasite load that it is carrying.
Okay, all right. Dwight, coming back to you, there's a question here. How do governments buy into the concept of polyculture and natural ecosystems when our history is based on monoculture? That's a tough one, Dwight.
Yeah, you're right. That's a very, very tough one. And that's why there are those of us who continue to interact with our different ministries of agriculture. You know, like personally, all the time I'm interacting with them, you know, you think that you're just butting your head against a wall. But I'm seeing a gradual change. And while it may not happen in my lifetime, you know, I think at some stage, governments will realize that some of what are inherited from our colonial past, etc., really was good for them and is not good for us. And we need to now walk away from it. You know, so it's something we have to push. It's something I do agree that governments are not yet there, because even in Jamaica, as we speak, you have investors coming in who say they're bringing new technology, and it is the wrong technology at the wrong time. So yes, it is a challenge. I really don't know how we do it, except for us, governments tend to listen to the masses of the people. If we can get a groundswell that says we need to change, let us get that going, and let's see how we can let them see that they need to listen to us, because we are being affected. You can't get up and just want to do what you think is good now, and it helps you for a 5-year term, and then after that, the rest of us have to be cleaning up that mess or suffering from that mess. So it is a challenge, but it's something I don't think we should give up on. I think some governments will listen if we speak with one voice.
Okay, I agree with you 100%. I think that we have to be consistent and keep at it. That's the only way we're going to get a solution. All right, we have a whole host of questions coming in.
It's similar, but we would say that because you have office, and likely happens, somebody's agriculture, and they just go put a D10 at one end and they push the other thing, and they put in a particular crop. And when you say agroforestry, you know, saying go in there and look at how you can incorporate your crop into the forest, you know, and see what's going on, right? So you can actually do that, and you know, set up an agroforestry system. Cropping, yeah, there may be somewhere the land was already cleared, and now you're just trying to make sure you put in multiple crops. So both of them are trying to achieve a similar thing in terms of biodiversity, but I would not consider them to be the same thing.
Okay, excellent answer. Leon, this one is the second be directed to any any of the two presenters. I'm using my thing as chair to direct it to you. A recent research has shown that sentinel plans are used for risk assessment and surveillance to support biosecurity. What are your thoughts on this as a climate?
Well, as was mentioned, what we're going to be experiencing, unfortunately, are increased invasions, and some of these invasions will come across on air currents that we cannot even anticipate necessarily. And so if we have pests of interest on our list of quarantine concerns, we can set up sentinel plans that are susceptible to some of these potentially invasive species that will give us an early indication that this particular incursion has arrived. So can be very visual that we are experiencing now.
All right, at the risk of...
Yes, the answer is yes.
Okay, okay. At the risk of, I keep telling Amira lives in a country, Dion, where she doesn't have a problem posing a question like this. But Dwight, I'm going to pose a question to you, Dwight, and you could tell me what is awkward about it. How effective plastic in weed control beds is retarding weed regrowth? Okay, let me see if I can. Okay, so I suppose the person is asking how effective is plastic mulch in controlling weed growth or regrowth and affecting seed germination. So they're talking about weed control and weed regrowth. In Jamaica, you have to be a little bit more specific because weed have more than one meaning. But anyway, Dwight, you know what I mean. Can you answer the question?
Yeah, okay. Yeah, the weed, we say, she's not talking about the weed.
Okay. She's not using a definite article.
Right, right. So yeah, that's a different thing. Yeah. In terms of effect, I know there has been some effect. We had a graduate student who did work on that, and you know, I could pull for that document and to get some idea of the actual efficacy. But I know just from general memory that you know, in it showed that it was effective, and they were able to produce crops. And she used onions in her experiment, and she was able to produce crops of onion using just plastic mulch in order to suppress the weed population. But in terms of more specifics, I would have to consult that document to see. But that information is out there. The research was done, and so you should be able to find that information.
Thanks for that answer. Nice short answer. Lighting up the pace and with persons to go. Dion, I think this is yours. The comment read natural enemy. Cuba has demonstrated the production of natural enemies in a number of facilities. Do you think some of those things could be emulated in the Caribbean? Well, in the Anglophone Caribbean. So,
yes, it's not that it hasn't been tried before. You know, we have done a lot of work on rearing. The iconic example of that is the management of the pink hibiscus mealybug. It was managed by biological control in the main, and mass rearing and releasing of the parasitoid and some of the predators of that pest was done in the region. So we have done it, and we have done many other mass rearing exercises with respect to natural enemy rearing. I don't know if Ian Gibbs is on the call, but certainly we have done a lot of work with parasitoids for diamondback moth. We have done work with parasitoids for citrus weevils. We have done a lot of work on entomopathogenic nematodes and fungi. The sustainability of these efforts is where we have had challenges. And I know that the Ministry of Agriculture in Jamaica is looking again at setting up some of these mass rearing facilities as we go forward. So, and we have learned from some of the experiences in Cuba as well.
All right, well said, thanks for that, short and sweet. All right, so we have another one, Dwight, coming to you on this one. And the question is, okay, so the question is, what elements of pest monitoring function, which were stated as being critical, in other words, what aspects of your presentation, Dwight, would you say are most critical? And are we just monitoring pests alone?
All right, I'm going to respond to that, and then I'm going to ask Dion to comment, because I think part of her thing was linked to that as well.
Okay.
But before I answer that one, I just want to comment on the previous question about Cuba. I saw the person who asked that question, and he and I were part of a team that visited Cuba to look at what happened there. I went back a second time to look at it. There's nothing that they're doing in Cuba that we can't do in Jamaica. We don't need to add anything. We have people with the skills, we have facilities that are similar, but it's just that we don't have the will to get it done. The ministry has done rearing, CARDI has done rearing, so it can be done. And what we're doing there, what they're doing there, I mean, we can scale up what we have done to get to what's there, but we just seem not to have the will. We focus on the other side. In terms of monitoring, pests, generally people tend to, monitoring is oftentimes very important, because we tend to focus on knowing when our pest population is getting to a level where it's going to start hurting us. And so we tend to focus on just monitoring pests. Sometimes the mistake we make is that we tend to focus on only monitoring the economically important stage of the pest. So for example, you will get a pest, and let's use diamond back moth because Dion just mentioned it, where people monitor the larval stage. I tend not to monitor the adult stage. But if your population increase, you're going to have a lot of laying, and you're going to have larval increase. And so it's how do we design monitoring to monitor the adult stage, or monitor the egg number of eggs we have, not just the economically important stage, which is the larva that does the damage. Because we can then, if we monitor just the larva, then it's a reactionary approach. We want to wait till the numbers come and we knock it down. If we monitor the adults and the egg laying activity, then we're being proactive. And so we need to first expand that to monitor all stages of the potential pest species. But again, in terms of monitoring our natural enemies, because you may go in and intervene when your natural enemy population was coming up and could have suppressed it for you without any issues. And so, yeah, we do encourage people to do a broader monitoring, just to get an idea where you're not just assessing the pest status, but you're probably assessing the health of the agricultural ecosystem.
All right, excellent. Onto the question now that I just added one about monitoring, what are the critical elements?
I probably, so when you talk about elements of monitoring,
Yes.
So in elements, I was, I'm not sure what they refer to as elements, because I was speaking to, when you talk about elements, it's pest activity, because pest activity and pest are different things. So usually,
That's true.
so you have to focus on, because you can have numbers that are not active, and sometimes you look at. So it's important to assess activity. It's important to assess numbers, and it's important to determine whether or not it's the economic stage, and or whether it's one of those other stages of the life cycle.
All right, well said, well said. Dion, since your agency is awash with cash, farmers over challenges associated with financing biodiversity conservation, and how do we attract funding to support agroforestry and some of these wonderful things that Dwight is talking about? Where does the money come from? Can they call your cell phone and you just write a check? So how are we going to get the money?
Well, the first thing I'd say to you, Dale, is to show me where the cash is that this organization has, and that would help greatly. But I want to defer to Steve on this, because I think Steve can answer that a little bit more usefully than I can in terms of the scope for funding for these types of activities.
Thank you, Dan. Without the permission from the chair, I'm going to respond. Yes, I think part of it has to do with how well we integrate climate smart agriculture into nationally determined contributions. I've been harping on this from the very first day. I mean, one of the reasons why we are conducting this webinar series is to emphasize the importance of climate smart agriculture. Not only active capacity, engaged capacity as well. And I you that the funding for agriculture that's out there nowadays is tied to climate finance. You're going to get very little support for any type of agricultural activity that you cannot link to some sort of climate finance initiative, whether it be through a readiness grant in the GCF or GEF funding or similar type of mechanisms. So I'm suggesting that there is a self-fulfilling prophecy here. You put the right things in place, and that is where the funding is going to come from. And again, once the ministries of agriculture, as we're trying to incorporate here in Grenada, once we get the Ministry of Agriculture to accept that there's going to be a climate smart agriculture future, one in which you have very clear guidelines on how you're going to comply with just comprehensive approach to climate smart agriculture, how you're going to incorporate your developments in the agricultural sector to your nationally determined contributions, then I think that is where the finance is going to come from. Whether, as I said, it be at the small grants level or at the level of a readiness grant or an ECA type agri project like is currently taking place in 6 countries in the Caribbean. So that would be my source of finance, other than personal funds from Dale and myself.
Well, Steve is number one in terms of resource mobilization in the Caribbean. Well, just to say, I mean, Steve is absolutely right. There are other options that exist for getting funding. I know, for example, in Jamaica, just recently, through the Jamaican National Bank, there was a climate initiative that was launched that was giving funding or very low interest loans to farmers. And I know also that there were a number of grant activities that came through the Special Climate Change Adaptation Fund. And Maxime, you'll remember that this is one of the things that was coming through many years through C-SAC and AC and all of those from proceeds from the CDM.
Definitely. But they're all climate linked. That's
yeah, they're all climate linked, right? So there are grant opportunities that exist. And right now, I can't speak to other countries, but right now in Jamaica, there are a number of initiatives that have grants. I know of one, for example, that you can get up to $150,000 provided that it is to an NGO, not a community-based group or a farmers group. It can't be to individuals. It must demonstrate how it is going to secure global environmental benefits. So show me how you're going to do land degradation, land degradation prevention, how you're going to do biodiversity conservation and so on, how you're going to have a livelihood component. So, okay, are you going to sell the produce from it? How are you going to sell it? Where are you going to sell it to? All of that kind of stuff. If you're going to develop products that are going to be trademarked as well, it's a big plus for them. If you normally it's $50,000 of matching funds, but your matching funds can be sweat equity. I would say a combination of sweat equity and funds is the best combination. And of course, you can also, if you have a project that is in multiple parishes, you can get up to 150,000. And I know that one intimately because I used to be the project manager for that. So there are a number of opportunities right throughout the Caribbean. There are other initiatives, the small grants program that I'm talking about, funding is available there. All right, so I see a number of other hands. Let me take Gregory first, then I'll go back to questions because we have about 10 minutes to go before we're out of here. So Gregory, you go ahead, please.
Thank you, Chair. I'm following up on the conversation that's ongoing. And I think we heavily involved now in the technical part of the process, where we sensitizing, demonstrating, and making suggestions, very clear suggestions for climate smart agriculture. Now, we had a serious issue with organic agriculture, similar to what's happening now. And the market did not pull the farmers' produce with a differential price. If a farmer is going to move from monoculture, and I was looking at the CARDI pepper system yesterday, production system. I take Antigua, very conventional, but probably effective in terms of producing yield and getting quality seed. If we were to introduce climate smart systems into that, what is in it for CARDI in terms of cost of production of seed, which may go up? What is in it for the farmer? And how does the farmer benefit immediately? Because once he starts to go polyculture, as Dr. Robinson suggested, and starts to monitor and as Dion suggested, and brings his farms and starts to become compliant, to measure, because compliance involves technical measurements. Once he starts to do that stuff, how compensated? And I am suggesting next week, when we have the closing out, we have a panel discussion, and the panelists take on some of the key points and make suggestions to the attendees as to how we're moving forward. There's a suggestion from on policy, and when I made my present, policy is important. How does the ministries get that across to the farming population? And I want to suggest we have a panel discussion, probably led by Steve, some of the critical points, we discuss them, and let's see how we can move that forward with some case studies or something like that. Thank you, Chair.
All right, point well taken. Excellent point there, and maybe you have given us an idea for the closing session. I definitely would look forward to that. I probably disagree with the chair with Steve, with a headache, but we'll see about that. I know in not having somebody better, you'll name him, but that's fine. That's fine. Max and myself will be back. All right, so let's go back to getting some of these last questions in. Pardon me if I don't get all of them in. I'm sure Desi will copy and paste them and send them to different persons. Somebody asked in terms of climate smart agriculture beyond protective systems, small farm to plan and manage the farm in ways to optimize ecosystem services. Dwight, I think that's for you. So beyond just the protective systems, what else can they do? Although I think you did give a list of things. And Dion also.
Yeah, you're gonna go first?
Well, since you expounded on it, just go ahead and then I'll add anything.
Okay, so it's in terms of assuming what you do to take advantage of ecological services that are offered. Now, one of the things that is I usually in a vacuum about ecological services. Most times people will make contact and they say, okay, how can I do this? And I often say that I got to see the farm. I have to see the ecosystem that you're talking about, etc. One of the things is that people tend to, what we have inherited, and it's not from our forefathers, it's from those who colonized us, where we think that, bush is a bad thing and you should just push it down. And that's, because bush is a bad word in some places, we say, call it natural vegetation and not bush. And so basically, sometimes you really don't have to do much, but it's just for you not to just clear the entire environment, just leave some natural areas and start, as I say, you're changing your mindset. Stop seeing bush as a bad thing and just leave some bush around. And even if you're, when you have protective agriculture, you mentioned there, one of the things there is that you tend to exclude everything from it. And usually, if you ever get a pest, get away in a protective agriculture system, it's the hardest thing for you to manage it, because what happens is that usually the exclusion system excludes the ecological services as well. And so usually when you set that up, you just try your best not to get anything in there, because you're not gonna get inside such systems. How do you, the general thing to benefit from ecological services is just not to trash the environment in setting up your farm. And, sometimes we have people who aren't able to assess it, but we have a lot of people around who have skill sets. A lot of people in the Caribbean have been trained, at several institutions who can do such assessments. And we hope governments, in terms of their extension services, have people there who could assist persons to assess that and to design systems that can benefit from ecological services.
Wow, thank you so very much for that. This must be the most lively panel we have seen. How do we better manage waste from farm to better address biodiversity and manage pests? Dion, you want to take that one on?
Okay. The thing about, and just to follow on from the point that Dwight made, you have to consider what is the waste trouble, because some can be deleterious. You will need to get rid of them. Of course, if it's pest infested waste, you have, and so to say waste is a very broad term. But I'm gonna assume he's talking about the useful waste that can be composted, and you have composting methods that can be used, whether the conventional one where you put the pile down and you turn it and turn it. And we have also the vermicompost waste that can be used. We have a demonstration and training center at Knockpatrick in Manchester, in Jamaica, in CARDI. And there we have composting activities taking place, but we also have a livestock crop interaction integrated system where we do recycle the waste within the system so that you're losing very little. So it just depends on what kind of system you have and what the wastes are and how that is useful to you in that particular environment.
All right, then the next question about managing biodiversity, waste for biodiversity, I think we have dealt with that already. Okay, so either of you could take this one, and I'm going to ask whoever is actually monitoring to please have the persons name themselves instead of having anonymous attendee. It really doesn't help the cause. Will planting of plants and climate change and has certain from you guys to determine. You want to
go ahead.
Do it? Okay, sure. Thanks for that. All right. So indigenous plants, by definition, are plants that occur naturally in a location. Endemic plants that are found only in a particular location. I think I got that right there.
You got it right. You got it right.
Did I get that right, Dwight? You're the expert. Okay, good. Perfect. So in terms of plants that have a natural proclivity for growing in a particular location, they would have been naturally adapted to the conditions there. So as a general rule, if you are growing plants that are already naturally adapted to a location, then yes, they do well. The question though is what climate change do, and I did an presentation showing that crop suitability will change under increasing temperatures. Some of it is going to be counterbalanced by increases in CO2. So for example, in our research, we found that when temperatures increase and even when rainfall decrease significantly, because there's increase in CO2, the plant doesn't have to open the stomata for as long, and therefore it can get the same amount of carbon per unit time, opening for a much shorter time. And therefore in that context, yes, you could have the plants to survive. Resilience though is a very tricky issue because you have to look at now a number of things. You have to look at the pest pressure for the future. You have to look at the extent to which the plant becomes salt tolerant, drought tolerant, heat tolerant, all of those things. Research is still in its infancy. We still can't say exactly how things are going to go. What I will say though is that CARICOM has been pushing us towards growing crops that are more naturally resilient. For example, crops that are not as exposed. So our root and tuber crops, for example, for growing drought tolerant varieties of different crops are options. And in that regard, I don't think we can spend the time to bring the plants here, especially those that take more than a year to grow and grow them. I think we have to use the modeling. And I'm not trying to advance my own ego here. I'm just saying you can ask anybody to do the modeling. You can grow the plant virtually, see what it will do, change the weather conditions to what 2020, 2050, 2090, whatever it's going to be, and see what the response of the plant is, and then make an informed decision about which one to use. That, I think, is the most economic way to actually build resilience into your ecosystems, right? So that's just a general rule about how we actually do it. Somebody was asking about cost-benefit analysis, where integrated pest management is concerned. There's a lot of work that is actually been done by that from RADA, I think, right, Dwight? You agree with me?
Yeah, there's a lot of work being done, but the thing is that you need to do it in specific terms. We can't, this thing where we don't have a lot of resources, we tend to like somebody does one for in one particular place, but it varies. And so, whichever area the participant is who's asking that question, we would need to have it done.
Okay, excellent. Somebody asking about monitoring associated with parameters and variables. What are we monitoring? I don't know to what. This is my Fruitful Ball Company Group Limited. Thank you for the Fruitful Ball. I don't know if it was something in your presentation, Dion. Can you clarify? Was it something in your presentation?
Yes, I think so. Monitoring in IPM is what I was speaking to. And if you remember, Dwight had mentioned that when you are going to IPM, you act on economic thresholds or actions thresholds, economic injury levels. And so, whereas in a lot of times you don't have a specific number for that, you have to be looking at your system to see what is happening there. Are we having adult moths? And if you're having, I'm using a specific pest example, moths, which are the adults of that particular organism, Lepidopteran organism, for example, you know that you're going to have egg laying taking place. So your intervention then would be something that is specific to either trap the moths, catch the moths in some way, knock down the moth, depending on what the moth is. And that is what you do because you have monitored and you've seen that activity increase. You can also look for eggs, and your activity would be then looking for a specific egg ovicidal property, soft chemical that you can put on, and this might be a biological introduction to get at the pest before it becomes a voracious feeding caterpillar. So you're really monitoring so that you can make an early interception of the problem. And that's what I was saying was monitoring. So you're either looking for the population increases, the damage increase, the actual stage that is present. You're looking at also the weather patterns that would influence the pests that you're particularly concerned with in the crop that you're growing, because whether it's raining or whether it's hot will determine what would be happening or what you can expect, and you can intervene early. In most cases, early intervention will save you a lot of losses and headache.
All right, well, thank you for that. Colleagues, we have overshot the time. There are two other questions. One is specifically directed to Dr. Robinson. So Dr. Robinson, you can take this one and then give me your wrap comments after that. The lady is saying, this is from Anna K. Maddox. She's saying that she's a small farmer from a farming community in Manchester, Jamaica, and most farmers in her community have been farming in agriculture for over 30 years and are used to doing things a certain way. For example, monoculture using exclusively pest management. How can we go about encouraging these persons to engage in a more sustainable farming?
Because we don't have time, But I hope she's listening. I hope the host will give her my contact since I'm from Manchester as well. I would be happy to have a discussion. And I mean, I do visit sometime to visit that area, so we can look at it and we can work with her to see how we can start that shift from what they used to something more sustainable. And for my wrap, I just want to thank everybody for the enthusiasm. Thank you for how you chair this. Thanks to my fellow presenter, Dion. And let's keep the dialogue going so we can move towards climate smart agriculture.
Thank you so much for that. Dion, there's a question for you. The question is, if plastic mulch is being touted as one of the intervention in a climate smart ecosystem, what about discarding the plastic when it becomes unusable? Isn't that going to create another environmental problem?
Okay, well, that the use of plastic in the environment is under review from a policy level right across the globe. And so what is being manufactured are plastics that we can biodegrade very easily. So in that regard, the technology will go that way. And so you won't have to be worried too much about that environmental impact.
All right, any wrap from you?
Just that it's very interesting to see that there is still this interest in learning about pest management in terms of the dialogue, the active interactions there are. But the mindset change is where we need to get to know, where everybody is thinking, let us try to do this better, because until we incorporate this kind of lifestyle change in how we do our things and how we see the environment and our responsibility within the environment, we will be stuck at the easy way out, which is just getting a spray can and kill the problem that way. So I like Dwight, I hope for continued dialogue, but I also want to see some behavioral change too in the stakeholder groupings.
All right, thank you very much. Colleagues, let me thank everybody. I really appreciate. Thank you for your long suffering, for bearing with me for this period. I really am very grateful. In fact, we still have 94 persons online. Dion, you made an excellent point about the plastic, but I want to also say, while we are transitioning to biodiversity, biodegradable plastic, we still have some way to go. But some farmers have already taken the lead. They have actually shredded the plastic and mixed it in soil now, use it as a potting medium, and it creates additional pore spaces in the soil. So for example, crops like ginger that had a significant nematode problem because of the heat in the soil, they have solved that by using the plastic. And that was as far back as 20, hold on, that was about 7 years ago, somebody just did that. So I'm amazed to see what they probably would have done now. And you can use anything as a potting medium. You can grow your plants using plastic anyways, as long as you have something to hold the moisture. So the point is well taken that we're moving and transitioning to something greater. Colleagues, let me thank you very much for staying with us, staying the course. Thank you so very much. Thank you, Desi, for the opportunity to chair. The OIT did an excellent job. Likewise, Dion, really, really appreciate it. I want to thank CARDI for this excellent job. We're almost at the end. We have one more week to go. And let me just thank everybody. I hope you have a wonderful rest of the day. For those questions that were not answered directly, I'm sure our presenters will get them from the very efficient Desi, and they will be answered in short order. Thank you very much. Have a wonderful day. Take care. God bless.